Sorry, we missed a couple minutes, but now we're going. Okay, so number 14, this is from the homework. The thing under the square root has to be bigger than or equal to 0, so I set this up. And I just start like solving it as if it's an equation. And I have negative x squared is greater than or equal to negative 4. And then I divide both sides by negative 1 to get rid of that. What happens to the inequality? It switches, it flips. So you got to remember that when I divide by negative 1 or multiply by negative anything, it switches. So then I'm like, okay, x squared has to be less than or equal to 4. And this gets like really weird. So if I take like the square root of both sides, I've got x squared has to be less than or equal to plus or minus 2.
Wait,
like,
just x.
Oh, x, sorry. It's like, what does that exactly mean? I have to, yeah, it means that x has to be between those two things. Here's what I do. I just stop and I think about it. And I think about negative 2 and I think about 2. And that like, for this, I kind of go back a step before I square rooted. And I think for this to be true, can x be bigger than 2? So like if x is 3, that's not going to work. So nothing up there is going to work. If x is somewhere in here, will it work? Like if x is 0, we're fine. If x is 2, I'm still fine. If x is negative 2, I'm still fine. All the spaces in here still make it work. But then when I back up to like negative 3 and square it, I don't get something less than 4 anymore, so that doesn't work. So like from this to here, I'm never quite sure what to do with this until I think about it. And I think like, oh, all right, well then x has to be between those two. So x has to be between 2 and negative 2. And if I wrote that the domain way, I'd go negative 2 to 2 like that with the brackets. That x is allowed to equal both of them. It's going to be everything in between. And by the way, don't forget about the thing that we stated originally, that x can't be 3. But is 3 even in this interval? No. So I don't have to worry about it. If my interval happened to have been negative 4 to 4, but x also couldn't be 3, well then I better break that up and go negative 4 to 3, open, and 3 to 4. Yeah.
How would you write the range for that?
I don't know. I'd have to graph it, and I don't know. That's not something that like I know how to graph. I could take some guesses. It's going to have an asymptote at 3. It's actually going to have a horizontal asymptote at negative 1, but I don't expect you to know that. So that's why you were only asked domain for that question. Yeah.
Number 12.
Yeah.
Wouldn't the range be negative 2.25 to?
How'd you get that?
Because you get that parabola at the bottom.
Setting the bottom equal to 0?
Yeah.
No, talking about the parabola.
In number 12.
Yes.
Okay.
It's not a problem though. I mean, like that whole thing is together. So since it's a fraction, I can't pull out like just that bottom and look at it as a parabola. It's like a whole big fraction, so it's kind of like graphing like we did before when we graphed the rational functions, where like we look at the two highest degrees. So this has a horizontal asymptote at 0 because the degree on the bottom is bigger than the degree on the top. So I know it has a horizontal asymptote at 0, so that's why I know the range is going to be everything except that horizontal asymptote. So it's not, there is no parabola on the bottom. That bottom is just part of the whole thing that you have to look at like the whole big picture of it. Okay. With that in mind for 14, does that make 16 any easier? I don't even know. 16 is like crazy. I would never put it on the test. Because now for 16, it was like the same idea with this crazy square root. So I knew that the thing under the square root has to be bigger than or equal to 0. So I started there. And I was like, all right, well, let me factor this. I took out an x squared first. And I had that. So then I was like, I took this into two parts. First I said x squared has to be bigger than or equal to 0. And x squared minus 16 has to be bigger than or equal to 0. You know how you would do that if you were like doing an equation, you would break it up. And I thought, well, x squared, isn't that always bigger than or equal to 0? No matter what x is, if I put it in and square it, isn't that always going to be bigger than 0 or equal to? So I figured this is always true, so like I don't need to, like, what do you call it? Whatever, I don't need to hone in on like what x is. X can be anything because that's always going to be true. So then I was just stuck with this, that like x squared's got to be greater than or equal to 16. And now I'm in that funky square root thing again, where like when I square root both sides, I get x is greater than or equal to plus or minus 4. I don't really know what to do with that. So I'm like, all right, let me think about it. Well, if x is bigger than 4, does it work? If x is 5, does this work?
No.
Yup, so x can be anything over there. If x is between them, does it work? Like 0? Nope, so nothing in between them works. Less than -4, like -5, that works. Oh shoot, I did mine wrong.
Oh.
I did mine totally wrong.
Huh.
So my domain should actually be -infinity to -4, and then, oops, and then +4 to infinity. Whoops, fix that, please. Let's have you guys try one, because obviously it's not very easy.
Yeah.
Like, yeah.
Wait. What
Yes.
if you had just like done like difference of 2 squares and like separating that into
If I did that, I'd have x plus 4, x minus 4 has to be greater than or equal to 0.
Yeah.
I'd still get x has to be greater than or equal to -4 and 4.
Yeah.
That's not really true.
Could you split the entire thing into like x to the 4th minus 16 x squared into difference of 2 squared?
Sure.
Okay. That's the never mind.
If you did that, you get x squared minus 4, x squared plus 4. No,
plus 4x.
plus 4x. X squared. So you'd still take an x out, and you still have the 0 thing going on, which didn't end up mattering because it's always going to be. So it's like, yeah, that would have been a little bit crazy. The fact that there was like an x squared here also made it like, whoa, really crazy. What if it looked like this? Let's try 2. Let's say like, what if we have the square root of x squared
that's awkward.
minus 25? Or what if you had the square root of does that even I don't know. Okay, I'm making this up off the seat of my pants. Or whatever it's called. I always get those phrases wrong.
Nobody says that ever. In fact, we say like the opposite of that.
What do you say?
It's off the top of my head.
Top of my head! There it is.
How the seat of my
The seat of my pants.
I just pull it out of
that
my
one.
butt.
I pulled it out of the pants. I don't know.
That's just school inappropriate.
Yeah.
I'm fixing my So basically I'm just trying to ask you, what's the domain? What can x be?
Wait, so
Is that like
Wait,
one
so what's the
graph
function?
or is it 2 different ones?
Let's say that's the function. Sorry. So say y equals the square root of x squared minus 25. Yeah, what am I even doing?
Yeah,
oh my
that doesn't-
gosh.
I'm so confused.
I'm so puzzled. Yeah, so am I apparently. There's your 2 equations. What can x be?
okay, dokie.
I was like, yeah.
So are we
Got it.
combining them or are they 2
I mean, you did
2
just pull them out of the
seconds.
seat of your pants.
I mean, it fell out of the seat of my pants. What do you want me to do?
That's gross.
Oh.
It's Thursday.
Right?
It's not like Friday. An excuse to act crazy.
Oh my god, the second one's not even gonna work. I'm redoing the second one.
Yeah, I was so
I
Yeah.
hate my life right now.
Yeah, I was
The
kind of wondering that.
second one you just said
just call it a day.
So wait, we're calling it a day?
Don't worry.
No, we're not calling it a day.
Don't worry, we only documented the whole thing.
Then I'll watch
It's a
it
shining
over and
moment in
over.
my career. Okay, so just do the first one and forget about the second one for now. Are you already finished?
Yeah. No.
It's still what?
And we're still done.
I know. It's okay. It's annoying when we break it into 2 videos because then I have to like upload them both separately and it's a pain in the neck.
Max, did you appreciate it as later?
Yeah.
Did you get that? So, whenever you see these weird, like, square roots with squares underneath, you gotta stop and think about it. Because to get this to work, to get x squared to be bigger than 25, I need to be working with -5 and 5, and I just need to think about what happens when x is bigger than 5. Yep, we're good. When x is between -5 and 5, we're not good. When x is less than -5, we are. Get it? What about this one? Haha. How about that? Sounds okay. Belching elephant.
Oh, what?
No? Did I do it wrong again?
I got it.
Yeah.
It's like
I forgot to switch it.
Yeah, it's the opposite.
It's -4 to 4.
Yeah.
I forgot to switch it. I forgot to switch it, okay? Obviously, this day is not cooperating with me.
We're done for the day.
Go order a cheesesteak.
Out during the
Forgot to flip the thing. Alright,
People go to ice, at least girls.
I'm skipping the ice. I'm gonna have ice cream after the cheesesteak. Is that okay?
Yeah.
Ice cream after cheesesteak? I'm sure that's fine.
Yeah, Simon. So when I subtract the 16 over here, I have a -x squared. Whoops, and
Yeah,
so my
that's what I
sign now needs to switch. Once my sign flips,
You switched it too early.
oh my gosh.
That was stress.
Once my sign flips, now I can think about it, so x squared has to be less than 16, so x has to be between -4 and 4.
Can't you just like add x squared to the other side instead of like?
When is it infinity? Like I really am like confused on how. Yeah.
Basically, whenever there's like an x squared underneath your square root, I need to stop and think about it. I need to say that the thing under the square root has to be bigger than 0. And I solve it algebraically. When I get to this point, I know that, hey guys, shh. I know that 5 and -5 are going to be the places where like I need to kind of look at. So if I put -5 and 5 on a number line and I think about it, if x is any number bigger than 5, that makes this work. If x is anything bigger than 5, including 5, this works. If x is between these two, it's not working. And if x is less than -5, it'll work again. So I know that x can be anything on that part of the number line or on this part of the number line. So x can be anything from -infinity all the way up to -5, can't be between them, and from 5 all the way up to infinity. Same thing here. I take this, what's under the square root, this has to be bigger than 0. I try to go solve for x. I bring the 16 over, When I divide by a negative, I switch the inequality sign, which is what I forgot to do. So now this has to be true. So I look at 4 and negative 4 because I know that's where it's going to split up. Anything bigger than 4 this time isn't going to make this work. If I pick 5, this is 25. That's not less than 16. So anything bigger than 4 is not going to work. Anything between negative 4 and 4 will. 3, 2, 1, negative 1. All of that will make this true. And then anything on the left won't. So my domain can only be then between these, from negative 4 to 4. So that's kind of...
I don't understand, like, when do you do the closed bracket or the...
For this, it's a square root, and I know that I can have 0 in a square root, so I know that I can equal 0, so I close the bracket. Okay, I know that I can have, this has to be greater than or equal to 0, because the thing in the square root can be 0. So it can be negative 5, and it can be 5, and it can be 4, and it can be negative 4. So I put the bracket on. Okay. Let's do limits and see how it goes. Maybe you'll be totally confused by the end of the day. Because you might have noticed I didn't bring my A game, apparently.
So you shouldn't use us anymore.
Limits!
Did it break up?
No, they just stopped inclusive, but they're back together.
We don't go to only infinity anymore.
Oh, I know!
Make another exclamation point under it.
Why?
Next to it, next to it.
We go beyond.
And now do like an upside down parenthesis. That works.
That is not an upside down parentheses.
Okay. We're going to have a big definition. Okay, it's only going to take you like a little space. But and we're going to have a crazy graph to look at to help us understand what limits are all about. So we're going to draw a big crazy graph. You try to replicate it. That's me making a weird bird noise.
Okay. You're never gonna see that ever.
What, this graph?
Yeah.
Yeah, but you're going to see crazy stuff. You need to know how to... I'm just putting it all on one graph, because why not?
What's with
How
that
hell
other
was in
point?
life?
Recal? Doubtful.
So can we just
What's
talk
with that
about
other
that?
point? That
Oh my goodness. If you make that one go the other way. Don't even. I guess that's okay.
That's great.
Oh, that hole's filled in.
Oh, look at that.
That's why
Why
there's
is
a
there-
dot in the middle.
Why is there a random dot right there?
It filled in the hole up above.
It's like the most confusing thing.
But holes don't exist.
Don't start.
No, but seriously, why is there a dot at
It filled in the
2, 2?
hole. So at 2, on the curve itself, there's a hole, but it gets filled in somewhere else.
Well, why is there just a dot?
It wasn't dot.
It's just a point.
You can't just have a random dot there.
Yes, you can.
You can do whatever you want.
Just
You
accept
can
it.
do whatever you want.
Heck, you don't make the rules with that.
Chill. Chill out. Love and understand.
Oh my gosh, I'm already zipping like
Man,
Can you guys see back there?
Yeah.
they
Oh,
can
that's
see,
without
but
size.
it's making their eyes explode.
because this is so.
Max, scoot down.
I don't like
You're in her way.
You're good. You're good. Well, that's worse.
No?
Wait, what?
Do you guys want to move up? There's a couple seats
I
if you
just
want.
got really offended that you're far away from the It's taking up.
On my bed.
I didn't say one of these.
I was mean, I'm just kidding.
Don't touch it.
Really piecewise. Piecewise out the wazoo.
Coming out the yin yang.
What's that?
Like, could you find it?
Sure, so could you. I don't mean it like all sassy pants like that. You could totally find this equation. That would be a really good, like, challenging problem. No! Like, find the equation of that piecewise function. You just gave me a great idea.
Do you really?
You could, though. You could be like, you know, when x is less than -3, I've got the line y equals 2. And when x is between -3 and -2, I've got, you know, some function that has that asymptote. And here I could have this one, and this one could just be cubic with a fill-in. That's really cool.
Yeah.
Okay, got it copied down?
Nope.
Let's even go like this. Recall. I'll do an A and a B. Okay. So we've talked about limits before in terms of going to infinity and going to negative infinity. So what I put up in blue, as x approaches infinity, positive infinity, what's the limit? What y values are we approaching as x approaches infinity? Infinity, okay? As x goes to infinity, the y values that I'm getting close to are infinities. It's going up forever. So the limit as x approaches infinity of f of x is infinity. How about this one? What's the limit as x approaches negative infinity of f of x? No. 2. Now this is supposed to be up at 2. I don't have it drawn perfectly, but the question's asking you, as x goes to infinity, what y value am I getting close and close and close to? Well, this y value is a horizontal line up at 2. It's going to be up at 2 always. So as x goes to negative infinity, the y values are 2. They're not even getting closer and closer to 2. They just are 2 in a horizontal line like that. So is that okay? Those two ideas. As x goes to infinity, my y values are going up forever, so to infinity. As x goes to negative infinity, my y values are at 2. I'm not infinity or negative, I'm just at 2. So, regular limits that aren't to infinity or negative infinity work the same way-ish. The definition's a little more important because two different things are happening. The old way with the blue stuff, as I go to infinity, I only have to worry about what's happening as I head this way on the graph, or as I head all the way that way. But an actual limit has to be doing the same thing from both sides of the point I'm looking at. So, let me look at 2 for a second. Here's my x value of 2, right? So I want to talk about the limit and what's happening at 2. Now, in the graph, I have an open hole and I have it filled in somewhere else above it. That's fine. It's still a function. It still passes the vertical line test, because when my vertical line would come across this spot, it would hit the point, but it's open here, so it's still only hitting one point. Do you know what I mean? Hopefully. So the vertical line test is fine, and the thing is still a function. Well, what's the limit as x approaches 2? So I go to my graph and I figure out what's happening as my x values get really close. Whoops, why did I write x? As my x values get really close to 2. Well, this part of the graph, as I'm coming along here, is reaching, like here it's at 4, here is at 3, here is at 2.5, here's at 2.1, here's at 2. What y value am I getting close to? 1. As I come from this side, here I'm at 0, now I'm at 1, now I'm at 1.5, 1 3/4, I'm almost at 2. What y value am I getting close to? The same one. The same, I'm still getting closer and closer to the y value of 1. The limit as x approaches 2 of f of x is 1. It's basically, a limit is just asking you what y value am I getting close to as I approach a certain x value. But the key is, it has to approach that value from the left and from the right. And that's what this is about. This little minus and this little plus means from the left and from the right. This does not mean the 2 is negative. It means as x approaches 2 from the left, which means like this way, from the left. This means the limit as x approaches 2 from the right. So in this particular example, as x approaches 2 from the left, my y value is becoming 2. Oh, I'm sorry, 1. Told you, sorry. And as x approaches 2 from the right, my y value is becoming 1. So therefore, the limit as x approaches 2 equals 1. I put this up. What's the difference? What's f of 2? What's the value of the function at 2? 2. Actual f of 2, what's the value of the function? Where is the function filled in? That's up here at 2. But that's like such a random thing. It has nothing to do with the actual function or its limits. So the definition of a limit is the limit as x approaches some value c of f of x exists if and only if, if you want to be all technical, the limit as x approaches c from the right equals the limit as x approaches c from the left. The exception is infinity. When I look at infinity, it doesn't matter what's happening from the left and from the right. When I go to positive infinity, I'm only looking at what's happening, like as I approach it from the left. That's the only way we can approach infinity, is to go from left to right. And when I look at negative infinity, I'm only looking at what's happening from the right, because I have to go out that way if I'm going to hit negative infinity. But for any number in between, I need to look at what's happening from the left and from the right as I approach that x value, and that tells me what my limit is. Yeah, sure.
So for -3, there wouldn't be a limit?
So at -3, so let's continue. Oh, there it is. The limit as x approaches, let's say -3 from the left. So the limit, and it's hard to write and think, so I want to make sure that you can get both. The limit as x approaches -3, so here's -1, -2, -3. Here's the x value of -3. As x approaches -3 from the left, so from the left, starting over here, coming this way. So if I come in this way, here's -4, -3.5, blah, blah, blah. What y value am I getting close to as I approach it from the left? 2. But the limit as x approaches -3 from the right, so same x value, but now I'm coming in it from the other direction. So at -2, at -2.5, at -2.9, 2 point whatever, 99, now what y value am I getting close to? 1. I don't care that it's an open hole. The open hole part doesn't matter. What actually happens at -3 doesn't matter. It matters kind of what happens is like for example, from the right, it doesn't matter that's an open hole, the limit is still 1. So, what's the limit as x approaches -3? Does not exist. Does not exist. Was that Nebra?
Yeah.
Doesn't she say the limit does not exist?
Yeah.
That's right, we talked about that, didn't we?
Yeah. I don't know.
We did.
We did.
We did it with infinity, I think we talked about it. Okay, so the limit as x approaches -3 overall doesn't exist because the limit from the left does not equal the limit from the right, and that's the definition. The definition is the limit exists as x approaches some value c if and only if the limit from the right equals the limit from the left. If that doesn't happen, there's no limit. It's really not that crazy of a concept, or that part of a concept. It's just new. How about what's the limit as x approaches 0? Period. Not right or left, just 0. As x approaches 0, from the left and from the right, what y value am I getting to?
0.
0. Okay? It's an open hole. So if I asked you, what's f of 0? What's the value of the function at 0? Does not
Undefined.
exist. Undefined does not exist, whichever. Okay? So at 0, since I don't have any place filled in, unlike at 2 when I had the point filled in above, I don't have any point filled in, so it just doesn't exist. God bless you. How about at -1? What's the limit as x approaches -1 of f of x? Negative infinity. So as I approach -1 from the left and from the right, I'm getting closer and closer to negative infinity. Some books will say that if I'm approaching an infinite y value, they'll actually say it does not exist, but they're wrong. It does. And most of the calculus professors and stuff like that will agree that if the limit approaches infinity, it's fine to say that. What if it was two different ways? Sorry to change the graph, and you don't have to write this, just make sure you understand it. If I put it that way and asked about the limit at -1, what would you say?
Positive negative.
Which one, if I just say the limit as x approaches -1 like that, you can't plus or minus it.
Why can't you plus or minus it?
Yeah, why can't it? Does not exist.
Why?
Because from the right, I'm at negative infinity. From the left, I'm at positive infinity. They're not the same thing. It doesn't exist.
Oh.
It just doesn't, yeah, I mean, like, the right and the left are two different places. I mean, even what if I did this? Gave you something crazy that, went like that.
Ha!
What would be happening at -1? Is there a limit?
No.
No. Because the limit from the left is, what's the limit from the left as x approaches -1? Positive 1. Alright, as x approaches -1 from the left, I'm here at 1. As x approaches -1 from the right, I'm negative infinity. Those two things aren't equal, so there's no limit. Question?
Oh, snake.
So when we do limits, we're gonna have a graph. You need a graph to do it.
Yeah, I mean, eventually we'll do, next year we'll do it with functions, but not this year. So this year we're just going to do it with graphs. Either that you're given, or I might give you a crazy piecewise to graph, and then answer limit questions about it. Yeah.
Wouldn't, for the thing that you just drew,
Yeah.
doesn't it already hit 1?
What, here?
Yeah.
A y value of 1?
Yeah.
Well, it's actually open. But
Well, what
yes,
about
this
right
whole thing is at a y value of 1. That's okay. Well, what if what I just drew, right? This is -2. What's the limit as x approaches -2? For this graph that I just drew. It's 1. Because from the left and from the right, I'm coming into the same y value. It's 1. And f of -2 is also 1. Everything's all happy and easy. There's homework. If you don't want to bring your book home, I actually I photocopied it because I just did. No real reason.
See, that's why I like you. So I don't have to take my book home.
But if you have your book at home, you don't need this. It's page 826. I know, we're hopping around. The last one.
Yeah.
Because books don't do things in books.
You should write a textbook then.
I should. I've thought about it many times, actually.
And you were like, too much work. Yeah.
It would be a lot of work, but. So that's 1, 2, 3. I don't think that's a bad thing to do 5
Yeah.
problems.
That's a lot of problems.
I don't know. I think 3 is a better number.
Alright, do the evens. So start at 28. So it's only going to be 28, 30, and 32. Because if you get it, you get it. Okay, who wants this?
Oh, please.
27 or
28.
Thanks.
Bye.
Oh, so only just some of them. Oh, yeah, they all have multi-parts. Did I stop
It's
it?
still going now. Do you want me to stop it?
Yeah, would you please?